when we have a graph, there's actually a quick way that we can determine whether that graph produces a function with an inverse. And that quick way is the horizontal line test. You probably remember this from previous math courses. We use the horizontal line test to determine if a function gives us a graph that is one-to-one. This test tells us that if a horizontal line intersects a function's graph more than once at any place, then the function is not one-to-one. So notice if we actually drew a horizontal line and we picked our horizontal line and we drew it up here, you might say, well, it looks one-to-one, or if we drew it down here, it might look one-to-one. But notice if I draw a line right through kind of what looks like the middle of my graph, I notice that it doesn't pass through only once. It passes through, what, 3 times? So this graph tells us that the function, because it is a function, does not have an inverse because it fails the horizontal line test. But notice again, the function passes the vertical line test. But in order to be one-to-one, in order to have an inverse, we have to pass both the vertical and the horizontal line test. So let's take a look at just 3 more quick examples. Suppose we have f at x equals 3 minus x squared. If we were to put that in our calculator and graph it, what we would notice is we get a function that looks something like this. Notice it would not pass the horizontal line test because I could draw a line that passes through more than once. If I looked at 2 minus x cubed, if I looked at that particular function, what I would notice if I went to graph that is it would look something like this. And this particular function would pass the horizontal line test. So therefore g of x would be invertible. Now I have h of x is 3 minus x squared, but this time I'm saying only use the domain 0 to infinity. And so now if I look at that graph, that means just this part. Now that would be one-to-one. It would pass the horizontal line test. If I restricted the domain, then I would actually have something that has an inverse.